it was immediately clear that Jacob is a generational talent.
We want to make all plastics infinitely recyclable.
Plastics are hard to degrade, but there's nothing intrinsically impossible about the chemistry.
We can reduce the carbon footprint of nylon 6/6 by up to 80%. There's no difference in the performance. This is exactly the same material. We've just made it from waste, not from oil.
A lot of people think that we can't do plastic recycling. We're going to prove them wrong.
When we go and we buy clothes off the shelf, maybe a sweater that contains recycled plastic, that has come from a plastic bottle. It cannot be recycled again.
Epoch's biological process will change that.
Turning that sweater right back into a sweater.
We're able to take a mixed waste stream, process it at very low temperatures, and at a very compelling pricing point, produce a virgin quality fiber, which is 100% recycled.
So we don't have linear recycling, we have circular recycling. At Epoch, we design molecular machines called Enzymes to break down and recycle plastics at a molecular level. We are a biotech company, so we're using biology as technology to solve a really big problem. Our goal at Epoch is to make circularity accessible and economical.
Sustainability doesn't have to come at a cost, whether that's in terms of pricing or quality of output.
Ultimately, we want to build a fantastic solution allowing us to recycle any kind of plastic, and reprogrammable biology is the way to do that. Right now, we're focused on recycling a material called nylon 6/6. It's an inherently incredible material, but we don't know how to make it sustainably, and we don't know how to deal with it at end of life. So at Epoch, what we do is we close that loop. We take nylon that would otherwise be made from oil, from polluting processes with a massive CO2 impact, and we drastically reduce that. We close that cycle and prevent that waste from entering landfill, incineration, or the environment. We've been producing nylon for slightly under 100 years, but we've never really been able to recycle any of it.
So from the first moment that I met Jacob, it was immediately clear that he is a generational talent.
I started the business when I was 18 years old. There's a high school research project. I wanted to find microbes, bacteria, that could actually break down different types of plastic waste so we could deal with this problem at scale. I think I got a little bit of flack from my friends in high school when I was spending lunch break in my science classroom trying to do experiments. I remember when I had my oh shit moment, where a sample of plastic had lost half of its weight. The sample I was trying to degrade had just disappeared over the weekend. That was incredibly exciting. I didn't quite believe it at first, but managed to repeat and managed to commit to myself that it was real. So at that point, I teamed up with a bunch of scientists to start a company. I realized at that point that it would be way more fun to do this than go to university. We take blended materials from the apparel industry, the automotive industry, things that would otherwise go to landfill or incineration, and we unbake the cake using our technology.
Biocatalysis is basically a process where we take enzymes and we use those instead of kind of nasty chemicals to do the reactions that we need to do. The advantage of enzymes is that we can tailor them by manipulating the DNA, which is where I say magic happens. We take the textile, we apply a special pre-treatment process. That material then goes into an enzyme depolymerization reaction. This is a solution that contains the enzyme. That basically will go straight into the reaction with the plastic material. So you can see this, it kind of looks like maybe if you've tried a home brew kit. We've got cells which are full of enzyme that are doing the reaction. Our enzyme's for plastic, but in your case, the enzyme is to basically make the alcohol. Over here, this is kind of right at the end of the process. So the enzyme has already chopped up plastic. And basically this is where we're getting the product, the monomers that make up that plastic material in the first place, completing the recycling system.
AI has been part of the process at Epoch from the get-go. It's really an intelligence multiplier for us.
I think often there are some negative environmental headlines around AI and its impact overall. But I think fundamentally we need to see this as a tool to get to sustainable solutions faster.
There are actually more variants of enzymes than there are atoms in the visible universe. So it's about finding the ones that do what we need them to do. And they are out there, we just have to find them. When we design enzymes, we have to look at it somehow. Here's a cartoon representation. It shows some of the structures in the enzyme. Enzyme engineering is all about how the amino acids interact in the protein. The challenge is that there are thousands of atoms in a protein. And as a human, even if I spent all day looking at this, I couldn't look at the whole protein. So with AI, that really enables us to look at all these interactions at once, and then also design it and come up with new solutions that are better. It's really nothing short of astounding. It's an amazing technology. The best part of my job is when my colleagues come back from the lab, fresh results, just ran the assays, and we see what we were looking for.
There are so many wins that happen on a weekly basis at Epoch, and it's great to be able to celebrate those. I think our team has decided that cake is the best way to do that.
We just had cake this week to celebrate a win.
So there's always a lot of cake at Epoch. So right now we're stood in our pilot facility in King's Cross, London. Really the focus of this facility is to use our enzymes at a much larger scale, make sure that we're stress testing the process, identify all of those problems before we start running into those problems at a much larger and more expensive scale. In this facility, we can process tens of kilograms at a time. And what that enables us to do is to produce much larger quantities to unlock customer partnerships, begin producing products, and really move the whole business case forward as well.
The demand for recycled nylon is enormous. Consumers are more than ever informed about what their clothes are made of, what their cars are made of, and the environmental impact of those materials. Regulators are tightening their expectations around waste, raw material usage, producer responsibility and recycled content. But I think the most exciting reason is that some brands, the leading brands, are not waiting for regulations to tell them what they need to do. They're proactively setting very ambitious sustainability goals, and they're working full speed to try and achieve them.
When we first started the business, we had a small lab space in Liverpool where we developed some of the fundamental science. A couple of years later, we moved into our purpose-built labs in central London, which is where we're based today. We then expanded to our pilot facility in North London, and now we're in our warehouse in West London. So behind me, we're building machines to recycle hundreds of tons of plastic every single year. We're using this to prove out our technology using industrial scale equipment, which then allows us to go ahead and build a factory 100 times larger. The plan from there is to build these factories all around the world, not just in the UK and Europe.
With our future sites that we're building, we hope to construct a world where materials flow through our lives in circles rather than polluting straight lines.
So when nylon is made using our product versus product derived from fossil carbon, there's no difference in the performance. This is exactly the same material. We've just made it from waste, not from oil. The fact that we can break down these materials at room temperature is really significant. Our process has a very low CO2 footprint. We're not using a lot of energy to do this. It's a massive reduction in alternative methods. Enzymatic recycling can reduce the carbon footprint of nylon 6/6 by up to 80%.
So with our warehouse, what we'll be able to do is show that our process works on a really large scale.
When I think about the 10-year horizon, sort of peering into the future and thinking about what is to come, I'm really excited. Plastics are hard to degrade, but there's nothing intrinsically impossible about the chemistry.
We're going to be able to design enzymes to essentially apply this molecular precision of biology at an industrial scale. That means we're going to be able to make all of our products sustainably, recycle all of our waste. There is no waste in nature. Every molecule is used for something else, and we can absolutely take inspiration from that for building the next generation of industrial processes.